In 2013, there was a new system that was discovered outside of the Kuiper Belt. It's named after Kepler, and it was taken by the Kepler telescope. The system is 2,767 light years from Earth. And when you think about it, that's not really a very great distance. It's about 56 million light years to the Taurus system to go to Aldebaran. Or actually, no, it's 64 million light years to get to Aldebaran. So 2,767 light years from Earth, not that far away. It's the Kepler planetary system that has 8 planets and a sun that is reportedly 5.6 the mass or 5.3 the mass of our sun. Interesting thing about this system is that K90, which is the main star. Let's see if I can just go like this. It'll probably be better. Sorry about my big hands, guys. It's a big hand night. Everyone give me a big hand. Arc. All right, so let's put a little light on the subject. This is pretty cool. There we go. There's K90. Hi, K90. K90 is the sun of this system. It's apparently only 800 Fahrenheit, and it's quite unusual because it's been maintaining that thermodynamic equilibrium, for as long as they've been watching it. It's a very large yellow sun that's only 800 Fahrenheit. So it also has a Mercury-like planet or astral body that is its satellite. Let's see, have a little fun with that. Let's see if I just hello. That's my borosilicate rod. K90b. All right, so K90b is right next to the sun, just like Mercury. And if that's only 800 Fahrenheit, begs a question about this being a habitable planet. Apparently, this body is about 3.8 the mass of Mercury, so it's a little bit larger, actually. But because their sun is 5.6 m, then there you go. So remember, all the planets in this system they discovered in 2013 are apparently 3 to 5 times the size of the planets in our system. It's a duplicate system, everything's a little larger, and it's a lot cooler because NASA is describing the planets in the Kepler system as rocky Neptune-like planets that are on the cold side, but they don't know. There's obviously no radioprofilometry and there's no spectroscopy. It's outside the Kuiper Belt, and they've been following these planets because they've been watching them blink and wink in front of K90. And there has been some beautiful photographs of our planet, you guys, taken by the Kepler satellite system looking back towards Earth of our planet. And I strongly suggest you go onto any of the NASA planet websites and look up, just Google Kepler 90 and hit the NASA website that comes up. You see a magnificent photograph looking back at Earth, and it looks like a star. And it's refracting the sunlight from our sun, and it looks like a star, and it's super bright, and it sends out a beam from both poles. Please look at the photo. Go on the NASA site and check out Kepler 90. So here are the planetary bodies. Kepler 90c, Kepler 90I, there's a 90d, quite a tiny little D for David, I think. Then this is an interesting system. Let me just push that up a little bit. That's K90f, and it's sort of Neptune blue colored planet. And again, there's no radio spectroscopy, and they are sending a satellite out to the Kepler system though, which is cool. And if they get that satellite out there by 2040, 2044, it'll all be a big hoo-ha, and we'll realize that what we have here is a system much like our own, and perhaps easily habitable. So you never know. So K90H, now that's their furthest out planet is the largest planet in the system, and it's, I think, again, 3 to 5 the mass of times mass of our Jupiter. And they do have a planet just before that. Let me move this lens, guys. I'm so sorry. Let me just give that a little tap. Let's see which one that is. Okay, that's K90G. Let me just put you right there. So this can represent K90G. So K90G is the planet right in front of K90H. And it has a higher density than K90H. And this is the first time, by the way, it's either K90H or this little fellow over here. And that's K90F. If K90F is the strangest planet that you've ever heard of, check this one out now. So let's go back to this. I believe it's K90G that NASA says is a puffy planet. And they believe because the planet doesn't give a strong gravimetric signature or density signature, they believe that it's a planet comprised of a lot of dust. So let's get you back over there. You get back on there. There you go. All right, so let's just have a little bit more fun. So that yellow lens right there, that represents K90H. And then we'll just turn this around. And then this could be K90G. There we go. See, guys? There's K90G. K90H is the large lens. And we'll just have a little touchdown right there. So these are the two furthest planets away from the sun in the Kepler system, Kepler 90. So my question is, how can we understand right now? I'm really interested in the gravitational signature of these bodies and what sort of gravitational signature that they give off, the electromagnetism of the planetary bodies. And because they're not continually being watched, it begs to question, even though they do have a 59.7 day orbital period, okay, and the transit of all these planets in the Kepler system, right? The transit of these planets in a group, mostly that they've seen right now, that's right, 59.7 days around the star. And it's just like our system. So instead of 30 or 31 days in a month, I guess they've got 59. It's pretty interesting. So if we can use lenses, perhaps, as a way to show how very interesting it looks. Let's just go like, oh, you naughty lens. Here you go right there, young man. Yay. All right, so look. Isn't it funny how when you shine a shitty flashlight on a lens, see this? Look at how the lens behaves. So I'm using the lens to represent the planet, right? Kepler 90F. But look how the light behaves, just like electron bombardment. If I just take that away. You see that? That lens deflects and bends the light and shows a unique similarity between photons and electrons. Isn't that interesting? So photons and electrons do behave similarly. They're relatively the same size. They travel at relatively the same speed. And unless there's a special exterior force or de Broglie incident or something else that's exotic that changes the nature of the flight path of the photon, then electrons and photons will be, taking pretty much the same route from their origin till their end. And so if you look at the way light shines through the lens or the planet, you can see how when the light bends, it just looks very similar to the cascade effect that you see when a planet is being bombarded by its sun. Let's go on this side and have a look, see what it looks like. There we go. Like this. See what that looks like. There we are. There's K90. And if we go like that, There, you see? There's the Earth-like planet right next to it, K90b. And watch how the electromagnetic and gravitational profilometry changes on that planet. You see that as a nice sphere now, don't you? All right, so check that out. Let's change the attitude of the star. There, look at that. So a lens works very similarly to the same as a gravitational or electromagnetic field passing a planetary body. And this is just a nice example that I've come up with to... Sorry about my camera, guys. There we go. So just a nice example that I've come up with to show the similarity between electrons and photons. But nobody wants to acknowledge that in mainstream science. I'm rapidly becoming labeled as a kook. But if you want to save your government several $trillion in atomic, photic, quantum light path studies and refraction and trying to identify electrons, don't waste your time with a super collider. Photons and electrons are almost identical. But gee, look how that affects that planet as the intensity of the sun, K90, increases. Now, there's no data about the way the electromagnetic radiation from the planet is affected by K90. You see that? Right? But we don't have any information from NASA or online at all about the fields around the planets for having this class of sun. But if it's a constant 800 Fahrenheit, which isn't that hot, then it must have a very interesting shower of slow or cold quarks, perhaps, or cold charged particles coming from it. So look how that star can behave on that planet. And just change the electromagnetic amplitude, and you get a really interesting pathway, representational photon pathway. Anyway, so I really urge you guys, go check out Kepler 90. It's a really interesting planetary system, much like Earth's, and look up as much as you can about it. I'm fascinated to find any information about gravitational fields, electromagnetic fields, or any electromagnetic equilibrium that's occurring in this system. It's got to be really fascinating. I hope you've enjoyed the way that I've been able to display these bodies and have a look at something that we may be visiting in the very near future. So remember that light years from Earth is LYFE, and that's life. You guys have a wonderful day and keep watching the stars.